So multiply these two matrices, and I put an equal over here with this, but I'm not going to use it because there isn't room. Okay? So what row do we want to start with and what column? Okay, we want to start with the second row, first column, right? I want to, so I'm going. You would ordinarily start with the first row, first column, but there's no reason you have to start with that one. Maybe there's something really interesting you want to see in the second row, first column. There's no reason you can't. I wouldn't do it with this notation. Go ahead and do it in the logical order, but it's going to be first times first plus second times second. A21, B11 plus A22, B21. Right? That's the second row times the first column. And where does it go? Why did I put it there?
What was that first tree we got?
Because it's in the second row in the first column. You know that since you have two rows, you're going to get two rows down here. And since there are two columns to multiply each of those rows by, you're going to get two columns. Now I could have a B13 and a B23. Okay?
And again, the way I always remember that.
Perfectly natural thing for many applications. Well, give me a third column, so I'd have to put this bracket out there a little way so I could write it. Okay, well, that really still didn't leave myself enough room. I'm bad at that. Okay, now I'll go ahead and do the first row times the first column because that's what you really want to see. Okay, so that's A11 times B11 plus A12 times B21, right? Okay, now I really didn't give myself enough room. I was ignorant. You know, I even moved that over.
And if you guys grew up in this area,
So I'd have enough room. I should have just not written it, but there we go. Okay, so now I'm going to do the first row times the second column. And of course, that result is going to go in the first row and second column of the matrix. So it's going to be A11 times B12 plus A12 times B22. And then second row times first column is going to be A21, B12 plus A22, B22. Very simple. Row, column. Row times column. Row times column. Okay? It's a very simple scheme, but boy, there's a lot that goes on. Okay? Now there's another way to write this. A little bit of shorthand. Notice that the one right next, well, on the expression A11, B11 and the expression A12, B21, what do those subscripts have in common? Well, what they have in common is that this number here on the outside is the same in both. When I say the outside, I've got four subscripts here, right? Well, the one here matches the one here, and it's the same in this term, right? Now, there's a reason for that. What does the one on the A mean? One in the first position on the A means that you're in the first row. So every term, no matter how many entries there are in the row, no matter how big the matrix, has got to have a, in the first row, first column, you've got to have a 1 here on the A. Every A has to have a 1 because every A is in the first row. So we're just going to cross the first row. A11, A12, there's an A13, A14, right? And then, well, this is from the first column. So the column is column 1, right? Okay? So in the column, this number keeps changing, right? Okay? Well, the column, first of all, the column, the last index on B tells you the column, right? So when you're doing first row, first column, the one here tells you it's first row, the one here tells you it's first column, right? Whatever the row and column, these numbers have to match for every term. So down here, well, that means second row, second column, and this has to be from second row and second column, because we're adding up what we get when we multiply the second row by the second column. Okay? So there we kind of have a pattern. And what changes? Well, it's the number in the middle. This means the first number in the row. This means the first number in the column, right? Then we go to second number in the row and second number in the column. Okay? So the, if you wish, the inner indices here change. Okay? Where the outer indices stay the same. So, I could write this using summation notation, which I hope you're familiar with. I'll explain it a little bit to be sure. As the sum of A1K times BK1, from K equals 1 to 2. Okay? Now what that means, we'll just discuss that a little bit off to the side. I'm going to do the sum from K equals 1 to 4 of A1K BK1. Okay? First of all, K equals 1, right? When K equals 1, we get A11 B11. And then we're going to add to K equals 2, because K goes from 1 to 4. So K gets to be 2. So now it's still, I mean, the ones are fixed. The number here is what changes. It's A12, B21. And that's your K equals 2. And the sigma here, the summation sign, just means you add all these. Okay? And then it's A13, B31 plus A14, B41. Here's your K equals 3 term. Here's your K equals 4 term. Okay? Make sense? Now this only goes up to 2 because you've only got 2 rows and 2 columns, but you see, all I got to do is change this number. Okay? To the length of a row. So if my rows have 3 numbers in it, of course my columns will also have to have 3 or we can't do the multiplication, right? The notation wouldn't make any sense, but that's okay because it doesn't make any sense to multiply a row by a column if they have different length. It's forbidden for good reason. It doesn't make sense. It wasn't handed down in stone tablet, this shall be forgiven, or forbidden. Didn't get enough sleep last night. We don't forgive mathematics. Okay, get the idea? So we can adapt this notation to matrices of any size. So then we have sum from K equals 1 to 2. Now we're doing the first row and the second column, right? Well, the first row, the A subscript is going to be A1K. And the B is going to be BK2. Right? And then we have okay. So when you see an expression like this, it means something tangible. It's not just something that is there to confuse you, it's there to simplify the notation. Then there's one other step we can make then. An even simpler way to to write this matrix? Well, actually, I'm just going to say, we could also write this matrix as Aij, like this, and then maybe put M by N. That's shorthand for this, okay?
No, we picked them up, we don't, we grew them.
And we just change this 2 to N,
They probably went before you changed.
and we write enough columns for M, okay?
Next day.
And I don't want to write that. I'll stop here for a minute. That's how you'd write this matrix, okay? What made me do that except being awakened by the dog at 2:30 a.m. Okay.